We have talked about taking numbers in scientific notation and converting them to standard numbers or regular numbers. We have talked about taking numbers written in scientific notation, whether they have a positive or negative exponent, and we figured out how to deal with those. And then we showed you, what about a number that's written in standard form, a regular number? How do we put that into scientific notation? So for the next example, we're going to look at several numbers that are written in scientific notation and try to get an understanding or a concept for putting these numbers in order. So if we look at this table, we have dollars spent by international visitors in the U.S. So we've got visitors from Canada, from India, Mexico, and the United Kingdom. And that those numbers written in scientific notation represents the amount of money they spent in the U.S. Now, what they're asking us to do is order the countries according to the amount of money the visitors spent, and we're ordering them from least to greatest. This is always a very important thing to pay attention to. Okay? Now, make one observation for me. What do you notice about the exponents on our base 10s? Are all the exponents the same? No, they're not the same. I have two exponents that are what? 7, and I have two that are 6. Let me ask you this. Which numbers are bigger? An exponent of 7 or an exponent of 6? An exponent of 7 means you've multiplied it by 10 an extra time. So here's what we're going to do. We know, if we're going from least to greatest, I know that 1.03 times 10 to the 7th and 1.06 times 10 to the 7th are going to be greater than the other two, right? Simply because they have a higher exponent, which means they've been multiplied by 10 an extra time. These numbers are going to have an extra 0 on the end, okay? Now, we know these other two, 1.83 times 10 to the 6th and 7.15 times 10 to the 6th will be the first two. So now the thing is, we've got to put these in order, all right? So if the base is the same and the exponents are the same, what do we look at to see if the number is bigger? Well, we look at the factor out front. So is 1.83 or 7.15 bigger? 7.15 is bigger. So the least or the smallest one would be 1.83 times 10 to the 6th. The next one would be 7.15 times 10 to the 6th. Now we have to put the other two in order. All right? We have the same base. We have the same exponent. So now we have to focus at the factors to see which one's smaller. Is 1.03 or 1.06 smaller? 1.03. So my next one would be 1.03 times 10 to the 7th. And finally, 1.06 times 10 to the 7th. What do you think is a common mistake that people make when putting these in order? Dimitri.
They're going to get confused with how many zeros to put on.
Yeah, that's basically what they struggle with. How many zeros are there at the end of this number? If you're not sure how to do these, what I would do is convert all of them into standard notation. Let me write them all out, and then I'll be able to tell. But a lot of people want to make this number the largest number because it has a 7 on the front. But we have to make sure we look at the exponents first and try to put those in order. So look at the exponents and try and put those in order is the first step. Try the got it in the middle of page 53. Do it now.